Hello and welcome to episode 124 of the HamCorp Training Manual. In this episode, we are unfortunately not ready to try out the DTPF just yet, and instead, we work on setting up an array of universal advanced assembly lines. We also start crafting parts for MarkV Compact Fusion and discuss how we're going to scale up power. The DTPF is going to have to wait a little bit. I will get to it, but it's not quite ready yet. I need a little bit more catalyst. What is that? Weird visual bug. But yeah, I need more catalyst before I can do anything, so I do have to wait a bit more. In the meantime, I have started to look into the MarkV Compact Fusion Reactor. To progress, I don't really need the compact. I could get away with the normal one, but the MarkV Compact Fusion Reactor has 4.4 overclocks. The Mark III and below have 2.2, so this is better. And I will have to make it at some point anyway, so I may as well do it now. For crafting the controller, there are no new materials at all. You have seen every single one of these before. For crafting the advanced coils, it's quite expensive. It needs quite a few circuits, an absolute ton of UU matter, and the research is a fusion coil block. The Mark III fusion machine casings, these need circuits as well, also some UHV parts, UU matter, and the research is a Mark II casing. As a reminder, the Mark II casings don't need any circuits at all. So this one is a significant step up in cost. And I would also need UHV glass, infinity catalyst frame boxes, UHV energy hatches. This is all okay. This is fine. So let's see if I can actually craft this stuff. So to do the controller, I do need to scan a Mark III Compact Fusion controller. And I'm not going to rip up my old Compact Fusion because that's stupid. So I'm crafting another one right now. I was able to do this. I just clicked start. I didn't have to do anything, which is nice. I can also very nearly make the Mark III fusion machine casings. I just need more neutronium, which is just a matter of waiting. So it might be time for me to upgrade my passive neutronium blasting as well. And the Mark II coils, this is where the real cost is. 560 coils. This is 145 megabytes of a crafting plan. Oh my god. But you know what's crazy? A lot of these things I have. It's just they're maxing out on buffer space. Like polybenzimidazole. This is not really a shortage. It's just I'm using a Super Tank 4, so it's maxed out at 32 million. Same thing with iron 3 chloride, phosphoric, sulfuric, silicone rubber. A lot of this stuff is not actually a problem. The only thing here that really is a problem is, I guess the xenoxene is kind of annoying, but honestly, none of these things are really that problematic. Like, it's a lot of stuff, don't get me wrong, but nothing that's fundamentally missing from my infrastructure. It's just the buffers are too small, or I need to provide more input material to make some stuff. But overall, this is pretty close to doable, even though it doesn't really look like it. On the current scale of things, I would say it's pretty close to doable. And once I get the DTPF going, I'll be able to make Molten Infinity. We'll come back to this later on, but this Molten Infinity is going to go straight into Infinity coils. Infinity coils are the first coils that require circuits. The Awakened Draconium coils do not, but Infinity and above all require circuits. So the cost has gone up. For the DTPF, I'm going to need 2,112 infinity coil blocks. That's a lot of circuits, and that's like 16,000 infinity wire, which, by the way, I should probably start using, because look at the amperage on that. It's a superconductor, 16,000 amps, max voltage. That's pretty good. And that's for 2x, so the 1x is 8,000 amps, but that's still pretty good. But I won't lie to you, I don't like how infinity looks when it's placed in world. Anyway, those are the two things I'm working on right now. Anyway, there's a lot of crafting to do. I'm not sure how I'm going to fill the time, but I'll find something. Well, after a little bit of investigation and just kind of watching my craft, I've identified two of the main bottlenecks. So one is obviously the blast smelter and vacuum freezer. These things are just slow by design, I guess. So I will probably upgrade the coils on this one, maybe provide more power, maybe make more, I don't know. And also another thing that's slow that I've noticed that is not really that surprising in hindsight is Oh, not the circuit assemblers, but the regular assembly lines. These are very slow. I make a lot of circuit parts in here, like the opticals, the wetware mainframe, the bio mainframe, and the bio supercomputer, I think it's called. You know, the tier before the mainframe. So all of those, I'm going to make some advanced assembly lines and dedicate it to them. I'm digging out a space here at the bottom of the circuit assembler pit, and I'm going to put them in here. And once that's done, things should progress much quicker. I've upgraded my power situation. I now have twice as many large Naquata reactors. This is still only, quote unquote, only going to be 3.2 billion EU per tick. I have had a few random power fails just when my power usage spikes, so hopefully this will help alleviate that. I've upgraded my neutronium blasters to UEV, so now I'm using all 8 parallels on each of these. But they're off for some reason because the mixer's power failed. Hopefully this doesn't happen again. Anyway, as you saw just a second ago, I have finished the wireless data hatches. So now, with a wireless assembly line receptor connector and wireless data bank transmission connectors, I can wirelessly transport data sticks from data banks into assembly lines. I still have to configure these, but these are all going to be dedicated to a bunch of different recipes. Basically as many as I can jam into these stocking buses before conflicts arise. But to be honest, I don't think it should be that difficult. I might be able to do like all 16 slots, which would be pretty good. To actually use these things, I'm gonna have to screwdriver the data bank, and that turns on wireless mode. And now, any data sticks stored inside these hatches will be wirelessly transmitted from here to, you know, wherever. I don't think there's a max range, which is pretty nice. As for what happens if I have multiple data banks, it just works, which is really nice. So if I run out of space here on the data access hatches, I can just make another data bank and I can make another transmission connector. And I believe it automatically links to all the receptors in the area, or maybe even in the dimension. It even says here in the quest that wireless data hatches are N-to-M instead of 1-to-1, which means one transmission can connect to multiple receptions, and also that one reception can connect to multiple transmissions. So what that means is I can have multiple data banks, and they will all transport their recipes into all reception points, which is pretty nice. That makes parallelizing a lot easier. And also, I have been running out of space for data access hatches, at least in the data bank that I have upstairs. So having a second one was something that was inevitable. And now I don't have to make copies of data sticks. I can just use the one data stick, and that's that. You know what I forgot about that I remembered, luckily? I can make neutronium in the fusion reactor, and this is a lot faster. The blasters here, they're pretty good. They do about 3.3 neutronium per second in total. But compact fusion does a stack in 12 seconds, which is about a bit more than 5 per second. So this is faster, and I have both going, so yeah, pretty good. Currently crafting my 1662 Mark III fusion casings, and I realized just now, literally just now, that I shouldn't have done that because I still haven't configured the advanced assembly lines. Oh, I'm such a dumbass. Well, I'll just cancel it once it gets to the assembly point, or when it's doing those crafts, and then I'll configure these. But yeah, crafting has begun. Not gonna lie, dude, the component assembly line is pretty slow for its own tier. This is UHV, and I'm making UHV parts, and it's pretty slow. Well, that's easily solved. And yes, I am sharing the component assembly line casings, which are by far the most expensive part. So my power demand has gone up a lot, to the point that these 8 large NAC reactors are pretty much not enough. Spamming more machines is possible, but very boring. So I think I want to figure out if I can get Mark IV fuel. The inputs for the Mark IV fuel are extremely unstable Naquata dust, Nether Star dust, awakened draconium dust, Arundum dust, Mark III fuel, and molten praseodymium. Everything here I already have or can easily get, except for the praseodymium. Molten praseodymium comes from praseodymium dust, which I can get from kind of 2 different methods, and I may have to do both. So the first is from the ore, which I can get from a meteor ritual. I'd rather not do this one, but if I must, I can get it like this, which means actually I probably already have some to start. Yeah, I have 13,000 praseodymium dust. That's a good start. That said, there is another way to get praseodymium. I can get it in molten form from extracting nanoresin. This is basically the optimized version of the ore processing, because I would need to put crushed praseodymium ore into a digester with chlorine, and this gets me praseodymium chloride concentrate. And that's an option, but there was a very helpful comment that I received in the last video, and that mentioned thorium-based liquid fuel. So here's the liquid fuel. This is depleted thorium-based liquid fuel. 500 liters of this gets me half a stack of praseodymium. It also gets me other stuff, including more praseodymium, a chance of it, which is pretty nice. And if I was a bee user, I would have indium combs and I could get more indium, but I'm not really short on indium. So this depleted fuel I can get from two methods. One is in a large Naquata reactor. This doesn't give me very much power, so I'm probably not going to do this. And it's also a lot slower, 25 seconds for 1 liter. The other method is to use the neutron activator. This was going to cost me power instead, which is fine, I don't mind. It's about 10 times faster. So I can process 200 liters from excited state into depleted. And excited state comes from this mixer recipe, helium plasma plus thorium-based liquid fuel. Thorium-based liquid fuel comes from another mixer recipe with high-density thorium, lithium, draconium, and mercury. High-density thorium is an electric implosion recipe with high-density thorium nuggets, and these nuggets come from wrapped thorium ingots. The wrapped thorium ingots come from uranium carbide thorium mixture and tungsten steel foil. And this is also just a mixer recipe. It does use thorium-232, which is a little bit annoying, but I think I might profit thorium-232 from doing this. Let me check. I will indeed. I'm going to profit a lot. So 20 thorium-232 goes into this mixture, and after all the processing, I'm going to get 320 thorium-232 dust. Almost. This is including the 80% chance of 8 thorium-232. But even without that, it would still be profiting thorium-232. So that's pretty nice, because the other way I get thorium-232 is this chemical plant recipe. It's just gross, and it's slow. So this is good. So this is how I'm going to get my praseodymium to make the Mark IV Naquata-based fuel. I also need tier 2 coils on the Naquata fuel refinery. These were very expensive in the past, but looking at it now, it's not so bad. So I think I could totally do this. And look at this. So this is the base output voltage for Naquata-based fuel Mark III, which is what I have. 9.5 million EU per tick for 4 seconds. Mark IV, 88.5 million EU per tick for 5 seconds. That's almost 10 times as much. So I'm going to go up to 32 billion EU per tick. That's a lot. And the depleted fuel gets me oganesson as always, a lot of Naquata dust, and sonarium dust, which is fine. Nothing too crazy. So that is my plan now. Alright, quick update on my advanced assembly line setup. So my original idea of using normal stocking input buses doesn't actually work because it can only see the first slot. So if I used normal stocking input buses, it could only ever do one recipe. So what I have here now instead is advanced stocking input buses, always pulling items, and advanced stocking input hatches, also always pulling items. These are gated to UEV because I need quadruple input hatches, UEV, a space assembler, optical parts. So it's a whole thing, but I can make these now. So these are 16 long, which is the max length. So there are 16 advanced stocking input buses on each of these assembly lines and 4 advanced stocking input hatches. The hatches are being shared between 2, and all of these are connected to a big array of ME controllers. Now let's see if I can explain what I've done here. So each slice of the advanced assembly line is on its own subnet, which sounds insane, but it makes a lot of sense. So each controller here is a different subnet, and they kind of alternate in color so that they don't combine. But basically what I have here is in the front 4 layers, there are 2 ME chests, and for the rest of the layers, there's a single ME chest. The front 4 have 2 ME chests because there are both fluid and item inputs on the first 4 slices. All of the ME chests on this right column here use block container ME storage cells because these can only hold one type, which is what I want. These are a lot cheaper too. They have 65K capacity, but they only use 1K storage components. And the first 4 layers also have 256K ME fluid storage cells. What happens is I put in my items through a method that I will describe in a sec, but I put in the items, and then the items automatically get pulled into the stocking input buses and hatches for every single assembly line on this array. And it's easily expandable because I just have to dig that way and add more assembly lines. Pretty easy. To make sure that items go into the correct slots, it's just the classical assembly line automation with storage buses set to higher priorities as you get closer to the beginning. So these chests on the right get filled first, and then this, and so on. This green subnet is basically just to handle the item and fluid routing. So the red is my mainnet, where the recipes actually go. And this pushes items into this green subnet. I painted this white. I'm going to change it to green just for clarity. So this is all the same subnet. So the items enter the green subnet, and they're stored in these ME chests in order from right to left. Remember that these ME chests are not on the green subnet itself. It's on the orange and blue subnets, the alternating ones. I have the storage buses set to bidirectional, which means I can use an advanced blocking card, which will allow me to avoid any recipe conflicts. And the nice thing about this setup is it's not dedicated anymore. These are, I guess, universal advanced assembly lines. So I can do whatever recipe I want in these, which means I don't really need to use these assembly lines at all, pretty much. Maybe for the items that are made in small quantities, I'll keep them. And also for tier skipping, I'm going to keep them. I have to keep them. But pretty much all mass production stuff is going to happen in these now. Thank you for watching this episode of the HamCorp Training Manual. In the next episode, we will craft Mark V Naquata-based fuel. The DTPF catalyst buffers are nearly filled, so soon after that, we can actually try it out for the first time. Compact 4 crafting will continue in the background. Remember when I said you may have to wait a while for this episode? I guess I was wrong. I honestly have no idea how I gathered up 15 minutes of content so quickly. See you next time.